Guys, now I am going to explain about machine learning project. For the project I am taking iris dataset. Okay, first, what is machine learning? Machine learning is an application of artificial intelligence. It mainly focuses on designing of systems, thereby allowing them to learn and make prediction based on some experience, which is data in case of machine. Actually, machine learning has been used in multiple fields and industries. For example, medical diagnosis, image processing, prediction, classification, and regression, etc. Okay. Coming to the project, we want to require some libraries. So first, we import libraries. Import libraries. Import NumPy as NP. NumPy is library used to handle multi-dimensional arrays. Okay. Import pandas as PD. Import matplotlib.pyplot as PLT. Okay. Next, import sklearn. Here I am loading dataset by using a scikit-learn from sklearn.dataset. Import load iris. Here this is the datasets. Okay, here datasets are visible. I am using iris dataset. Okay, from sklearn import matrix. Here matrix is used for defining error. sklearn dot from sklearn.linear model. I am using here linear regression for solving problem. Okay, from sklearn.model import try and test split. Next, import seaborn as SNS. Okay, here something has mistake. Matplotlib. Okay, next, steps involving in solving a problem with machine learning techniques. There are techniques: data processing, define error, split the data, train model, and prediction. Okay, first, data processing. In data processing, here we load data set. Okay, data processing. Loading data set. I am taking variable as iris is equal to load data set. Next, print iris dot describe. Means here description will get. See details about iris data set. Here number of instance, attributes. Instance means rows, attributes means column. Okay, here there are 4 attributes are there on 150 rows are there. Okay, for getting attributes details, here I am taking features as a variable. pd.data frame features iris dot data column equal to iris dot feature name. Okay, features name. Next, see run. Okay, here we get 4 attributes data. Now another one is target. For getting target, I am taking target as a variable. Target equal to pd.data frame iris.target comma column equal to column name as also target. Okay, run. Next, target. See here we get target data. So for combining both, I am using here concatenation method. Okay, for combining. So here I am taking df as a variable, pd dot concat is variable names. Okay, target. You are here, you want to mention axis also. One is column. Okay, if you use 0, it combined by row wise, so we want here column wise, so I am given 1. Okay, next df equal to, see here the target and 4 attributes are combined. This is how we combine 2 data sets. Next, to generate summary of data set, here I am using describe function. Okay, df dot describe. See here we get mean value, standard deviation, minimum value and maximum value of each and every attribute. Okay, next, correlation. We are finding here correlation between target and attributes. So correlation between target and attributes. Correlation is a statistical technique that can show whether and how strongly pairs of variables are related. Here I am taking variable as c. Okay, df dot correlation +1 c. Here we get correlation values. We can observe how the values are, how the attribute are correlating with target. Okay, next we can see in map also, sns dot heat map correlation. Here we get view map. Okay, here light color indicates higher correlated value in compared to thick has less correlated value. Okay, next step is normalization. Normalization is a scaling technique in which values are shifted and rescaled so that they end up with ranging between 0 and 1. It is also known as min max scaling. Okay, for that we are here want to take an x and y values. Here x values indicating higher correlated values. Here paddle length and paddle width highly correlated with target. See here you can 0.9 and 0.95 as both are highly correlating. So here I am taking as a x value as paddle length and y value as target. Here x df is equal paddle length. This is highly correlated value attribute dot values. Only you are taking values, only equal to df the target dot values. Okay, before normalization the values like this. So print x right here. Before normalization the values are 1.4, 1.3. See, you can see here the values 1.4, 1.37. So same values you get. Now after normalization, so here I am doing normalization. X scalar equal to mean. Okay, next capital X equal to X scalar dot fit transform form of X reshape, because we are getting in one shape, so we are reshaping. Okay, next X equal to X minus 1. Okay, next same we want to do for Y also, normalization. See here, y scalar equal to mean max scalar, y scalar dot fit transform. Okay, next after normalization, after normalization X print X. See here the values came in between of 0 and 1. Here previously 1.4, but now 0.6, 0.6. See after normalization. Now next step is splitting the data. Split the data into training and testing data. Here if you assume that data is 100% in training data, and training data occupies 80% and testing is 20%. Okay, so I want to split the data. X train and X test, Y train and Y test equal to train for X comma Y. For X comma Y variables we are splitting the data. Okay, in 80% and 20%, 80% of training and 20% of data. Here we can change percentage also. Test size equal to 0.2. 0.2 means training data is 80%, testing data is 20%. If you want to change also you can change. Okay, 3 means training is 70, testing is 30%. This is how we can split data. Next, linear regression, training model. Want to train the model. Okay, here the model I am using is linear regression. In statistics, linear regression is a linear approach to modeling the relationship between dependent variable and independent variable. Formula here we are using intercepting y equal to m into x plus c. Here m is slope, c is intercept value. Next, model equal to, see this is, here we can write train model. Okay, linear regression model equal to linear regression next. Here the shapes are, I think, forgetting in all in one shape. Here changing the shape value. Okay, train equal to x train dot reshape -1 comma 1. Okay, next you can change here test copy and pasting. Okay, y train y test y test equal to y test dot reshape. Okay, next fit the model. Here now I'm doing fitting model, so just model dot fit x train comma y train. Just run. Okay, after fitting model we want to find out intercept and slope value. Finding model dot, here coefficient means slope, okay, this is a slope value. Next intercept, here intercept, see here this is intercept value. Next plotting the regression line upon the training data set. By using a training data set we are plotting the regression line. Okay, for that I am using scatter plot. Scatter plot means a graph of plotted points that show the relation between two set of data. So plt dot scatter plot, scatter x train y train. Here I am using color, it's blue. Okay, plt dot plot x train comma model dot intercept into here into not plus. Okay, place model dot coefficient into x train. See here you can change the graph color also, color equal to red. This blue color represents x train and y train values, and this is a red color line represent the intercept and slope line. We can also call as linear regression line also. This is okay. Next last step is prediction. Okay, I am taking variable as prediction equal to model dot prediction, okay, of x test. I am here x test as a reference. Here linear regression has no object of prediction. Okay, it's not prediction, it's predict. Here you can see prediction. See, here you get prediction value. Okay, you want to get, you can change prediction equal to -1. See, here the values came side by using this one. Okay, next plot the graph, plot the predicted values against the target values. Okay, here same I am using scatter plot. Okay, pld.scatter. Here I am x test comma y test. This is color blue. I'm taking a blue color. pld.plot x test comma reduction. Next here color equal to red. Here this is the prediction line we get here. Okay, now the result you can pd.data frame. We are saving in a list all things. Okay, zip file x test y test prediction column names, just x value, just target of x, this one x, target of y value, this one. Okay, next prediction y. Okay, here result. See, this is x value, target and prediction. How we can find out this? This is how we can predict the here we can use head means just top 5 values will come. Okay, now we can find the error. What is the error in actual value and prediction value? Okay, first print. Here MAE is mean absolute value. Okay, matrix dot. Here we are finding first mean absolute error. Y test comma prediction. Okay, see, this is a mean absolute error. Now mean square error, SE mean square error, can change here. Here this is mean square error. Next print RMSC root mean square error. Okay, here np dot dot square matrix dot mean square error of y test prediction. Okay, this is how we can predict the model. Okay, this is the errors. Okay, just that's all. Thank you for watching.